Hi good people, Titus here for part 3 of our Asteroids mini-series, and in this video we'll tackle creating the code to translate our ship from one side of the screen to the other. Let's not waste any time and jump right into it. Okay, to demonstrate the problem at hand, I got a simple paint drawing here. We'll imagine this is our ship. The green part is the visible screen. Essentially what we want to be able to do is when the player goes to one side of the screen, it should kind of disappear, but then show up on the other side. And then same thing if they're going through one of the top or bottom, it'll kind of disappear, and then it'll come kind of back around, kind of like that. And we'll be doing that with the shooting and the asteroids as well. So there's a couple different ways we can approach this problem. One way, of course, you can use box collision, and you can teleport the actor based on a collision event. I think a simpler method is just divide the screen. It's an X and Y coordinate. You can basically track the objects are within a certain XY bound, and then if they're not, you can just simply multiply the value by its negative counterpart, and it'll basically translate it to the other side. So I think that'll be the route we take, and I'll kind of show you what I mean. So let's go back into our blueprints. And first, starting off, we need to figure out the range of our X and Y coordinates. Even though this is a 3D game, we're just going to ignore the Z axis for now. So let's open up the ship. And we're looking here. Now, if we go to our event graph, we can find a blank spot. Let's do event tick. This runs every frame, so it'll be good to track. We can come into a print string, and we can get a reference to get actor location. Pretty simple. Drag that into here. It'll convert that, and now if I compile, there's going to be an issue with it. If we play, you see it's showing all zeros, and if I move around, it's still all zeros. So what's going on there? Well, that has to do with our components layout. Everything is a child of the default scene, and when we're playing the game, the default scene is at center. It's like this little circle thing or whatever. It doesn't move, so that's why it's showing 0. So what you can do to get around it is you can just take whatever parent object you want to use. In this case, it might make sense to use the collider. Just drag that up, replace that default scene root, compile, and now when you play and you move, you'll notice it actually tracks. So now if we get to the top of the screen, we're about 1,000 on the X, 1,500, so it looks about 2,000, I would say. And then since we're dead in the center of the screen, it should be around negative 2,000 for the bottom of the screen. Which, yeah, that's about right. Maybe a little bit less, but we can start there. So for the code, we'll just go ahead and disconnect this for now, so we can use this a little bit later. Move it out of the way. Okay, so we can do, we'll do get actor location. We'll come off that into a break. And then from the break, now remember when we're talking about the screen, you have an X and Y. The X is the up and down, or top and bottom, and the Y is the left and right. So let's just get the up and down set up first. So that's going to be the X value. So we can come into the X value into a multiply. We can multiply the value by simply -1. And we can come into a make vector. And then we have to take the other values and just drag them in like so. And then off the event tick, we can come into, actually just press B and click in the graph. So we can go into a branch. And then off the true condition, we can come into a set actor location. And I gotta move these nodes out of the way. And the location I want to come into is this vector that we just made, like that. Now we need to figure out the condition part. So what we can do is right after the break vector, we can come off the X, because that's the up and down, that's what we're looking at. And we can come into a in range float. And then our values were -2000 and 2000. So now basically this is going to evaluate to true if our character is between -2000 and 2000. Basically when they're inside the screen. So -2000, 2000, if they're in here, it's going to evaluate to true. So if it evaluates to true, we don't want to teleport. We don't want to do anything. So basically when this comes in, if we plug this in, we would want to come off the false pin, which you could certainly do. I'm just going to actually go into a not Boolean and then plug this into here, because I find it's easier to read code backwards, or at least I find that a lot of times when you're debugging, you're reading backwards. So reading backwards, I see that obviously we're setting the actor location, and we're setting the actor location if we are not in between these values. So it's a little bit easier to read. I mean, you certainly could just plug it straight into here and come off the false condition. Either way, it doesn't matter. Just the underlying logic is going to be basically the same. So we're going to compile and save. So now if we go ahead and rock it up, it should teleport us to the other side here. We can come at an angle, and then you can see it's working pretty good until we get to the side and we veer off, and then we're gone. So now we need to do the Y value, which is the left and the right. So it's kind of more of the same, so we can actually pretty much kind of copy all this actually. So I will deselect tick. I gotta move this out of the way again. Actually, we got to figure out where it is. So we'll plug this in here, and then off the false condition, we'll come into here as well. So we can compile and save. So for our Y values, looks like we're at -2000, around -3000, maybe a little bit more. So that means +3000 should be around this way. And we're off screen. It's a little after 3000, so look like 3200 kind of. But all right, let's see. So let's go ahead and just delete that. We can go ahead and press B, we'll click into a branch node. Now we want this, because this evaluates every frame, we're gonna wanna come off the false pin into this. But there are scenarios where, like if you're hitting a corner, it makes sense to also come off the true pin into this Boolean check as well. So you'll wanna hook up your nodes kind of like this. And then I'm gonna add a reroute node here, like so. Okay, but then I can I'll actually just manually do this out, just so you can see it. I can do get actor location. We can break that vector. And then we can come into the X into a make vector. And remember, we're messing with the Y this time, so we'll come into a multiply. We'll multiply it by -1 to turn the value positive or negative, basically left or right. And then we'll plug the Z value in as well, and just add a little reroute node there. And then off the true pin, we can come into a set actor location, reference the self, and plug in the value. And then we just need to figure out the condition. Now for the condition, we want to come off the Y value and say in range. And we'll plug that into a not Boolean. And I'll explain that again in a second. And the minimum values look to be about negative, I'm gonna try, we'll try 3100. And so negative 3100, positive 3100. And basically what we're saying here is, you know, when the ship is going left to right, if it's between negative 3000 and 3000, that means it's visible, it's on the screen. If it's outside of those bounds, it means it's in the orange and we should teleport it. So if it's negative, it's going to multiply it by -1, which is going to teleport it over here because that's the positive axis. If it's above 3100 positive, then it's going to multiply it by -1, flip it negative, and bring it over here. So if I did that right, compile and save, hit play, and if I rock it either to the left or the right, I should flip around to the other side of the screen. And it looks to be working reasonably well, so maybe, also looks a little bit short, so maybe 3300, but it looks okay. And then if you wanted to, you can also go at an angle, and then it should still work where you're kind of flipping through the screen just kind of like you're used to. And then we'll address the other mechanics later when we're doing, I think we're going to add maybe fuel, so the player won't be able to infinitely rock it like this. And we can also maybe add some linear drag too, just for, so it's a little bit easier to move around. So let's go ahead and do that. Select the collider. And down here, linear damping, looks like there's a little bit, 0.01. I'll just change that to a 0.1. So now when I basically do that, I should over time kind of stop. And you may or may not want that. I think it's a little bit easier for aiming because sometimes you want a little bit of precise. So that's not necessarily an accurate to space thing, but more of a game mechanic thing. And then the other thing we'll need to figure out is the viewport. So let's actually look at our camera. Right now our camera, we don't have constraint aspect ratio. The reason that could be an issue now is if you look right here, I bet you we're going to teleport early. Yeah, it looks like we are. So you can kind of see it. It looks okay on the top and bottom, but basically depending on the player's aspect ratio, it's going to mess up. So we can actually lock that. And I think these defaults will probably be okay. So it'll probably add some black bars on the side. I guess the best way to do it is maybe do it as a separate window. So now if you're in like a smaller window, that kind of looks okay. And then left to right, that doesn't look too bad. But if you do it again and you max the window, it should keep that same dynamic. And that looks good. And that looks pretty okay as well. Alright everyone, I think we'll cut the video here to kind of keep it short, but in the next one we'll tackle the shooting portion of this prototype. But as always, thanks for watching, consider subscribing, and we'll see you on the next one.